Hello. With this video, we start the series on 3 antiepileptic drugs: Tiagabine, Vigabatrin, and Stiripentol. The series includes an introductory video. This video, videos on retrosyntheses, and on the resulting syntheses. Here we present the systematic name, CAS number, structures expressed in 2 and 3 dimensions for Vigabatrin. Because it is still supplied as a racemic mixture, the 3-dimensional structure represents one of the enantiomers. In its structure, an amino group attached to an asymmetric carbon and a vinyl group stand out. For Tiagabine, the 2 methylthiophene heterocycles, the piperidine, and its asymmetric carbon with R configuration stand out. For Stiripentol, which is also supplied as a racemic mixture, the allylic alcohol and the benzodioxole fragment stand out. We can say that Tiagabine has its origin in nepocotic acid, a restricted conformation analog of the neurotransmitter GABA, which, being 2 polar, does not have bioavailability in the central nervous system. Optimization efforts on this compound, increasing its lipophilicity, resulted in Tiagabine. Vigabatrin emerged from the research of olefinic derivatives of amino acids. Stiripentol emerged from the research on derivatives of the general structure shown here. The 3 drugs have in common, through various mechanisms of action, that increase the activity of the neurotransmitter GABA, and in this way, eventually, reduce the potential to produce seizures associated with epilepsy. In Vigabatrin, the vinyl group is key for its covalent binding with the enzyme. In particular, Vigabatrin acts as an irreversible inhibitor of GABA transaminase, the enzyme responsible for the degradation of this neurotransmitter, by reacting with the cofactor of this enzyme, pyridoxal phosphate, to form covalent bonds with the cofactor and the enzyme and inactivate it. Here, the proposed mechanism is shown in a very simplified manner. Tiagabine requires the nipocatic acid fragment to bind to the GABA transporter, and the lipophilic fragment attached to the nitrogen to improve its affinity with the transporter and its bioavailability in the central nervous system. In Stiripentol, the hydroxyl group can be replaced by a keto group, and it has been found that the derived semi-carbozones and pyrazolines are active. Tiagabine was patented by Novo Nordisk, introduced in the United States by Cephalon under the brand name Gavitril. Vigabatrin was patented by Richardson Merrill, introduced in the United Kingdom as an anticonvulsant, and later in the United States by Lundbeck under the brand name Sabril. Stiripentol was created by Biocodex, introduced in Europe and later in the United States under the brand name Diacomet. The 3 drugs are indicated for the treatment of various types of epilepsy. The 3 drugs are administered orally. Tiagabine and Vigabatrin have excellent absorption. Here, common adverse reactions are shown, and rare ones that can be severe and require medical supervision. For Vigabatrin, there is a notable risk of vision loss. Here are some relevant physicochemical properties for the 3 drugs. The resulting retrosynthesis and synthesis will be presented in the following videos. Thank you for your attention.